Hey, our second video and our last video for this lesson, it'll be pretty quick. We have another situation here. This one, a watering can is filled with water. It sits while some flowers are planted. Then the watering can is emptied over the newly planted flowers. Our job is to create a graph given this scenario. So let's talk about labels, and then let's talk about continuous versus discrete, and then we will draw it. So a watering can was filled with water. I'm going to, and then we're talking about flowers. I'm just going to call this graph the watering can. Cool. Watering can. In terms of independent versus dependent variable, a watering can is filled with water. It's planted, flowers are planted, and it sits, and then it's emptied. It sounds like I'm showing water versus time. So time that it takes to fill with water, it sits, and then it then gets dumped out. So time versus amount of water. What depends on what? Does the amount of water depend on the time, or does time depend on the amount of water we have? I'm going to say time is going to dictate how much water is in the can. If I'm looking at the end of the story, there's going to be a lot less water in the can than if I look at the middle of the story, for example. All right, so time dictates the amount of water in the can. So water. And then I am going to talk about discrete versus continuous. Thinking about this, are we talking about individual points? Is there individual points in time that we're like sort of taking a measure of this? Or is this happening over time? Is the water filling up gradually or whatever else? And if I think about this watering can is filled with water, so that takes time and it gradually goes up. As the water pours in, it's continually getting taller and taller and taller in the watering can. It then sits there, and the time sort of continues, and then the watering can is emptied. Yeah, we're talking about a continuous graph. There's not discrete points. We're not saying like, what is the snapshot in time at 1 o'clock, at 2 o'clock, at 3 o'clock? Like it's just giving us time as a continuous sort of concept. So this is going to be a continuous graph because of that. And now I have to talk about how it's going to be graphed. Let's look for key ideas. A watering can is filled with water. So I'm seeing the like level of water increases. It sits a while, so then it stays the same. And then it gets dumped out on the waters. So then level of water decreases. So to draw this, we're probably starting with an empty watering can. So I'm going to start at 0, 0. And water typically comes out of a hose pretty continuously. It might be fast or slow, but it's going to be fairly continuous. So water is going into the can continuously. And then after that, it stays at a certain level, and nothing's going to change of that water level until we dump it out onto the flowers. And typically, I like to be nice to my flowers when I water them, especially if they've been newly planted. So this is probably going to happen pretty gradually. It's probably going to happen a little more gradually than when it was filled up initially. And it's okay if my graph is longer than my actual like axes. I can continue these axes for as long as I need them to. But eventually this water can is going to be empty. And so it's going to meet that x-axis. Wow. Awesome. And I'm done. Have at the problems for lesson 4.7. Enjoy them, and don't hesitate to ask questions if you have any. Thanks for watching. Bye.